In this video, we will demonstrate how to perform pilot titration. Titration is a laboratory technique used to determine the concentration of a solution by reacting it with a chemical of known quantity until the reaction is complete. While precision is essential in titration experiments, achieving accurate results doesn't always have to be time-consuming. A pilot titration can help streamline the process while maintaining high precision. A pilot titration is essentially a trial run that provides an estimate of the volume of titrant needed to reach the end of the titration, known as the endpoint. This approach not only saves time, but also improves accuracy in subsequent titrations. It is particularly valuable when working with new samples or systems with unknown endpoints. Which of the following is true about pilot titrations? Select all that apply. The correct options are the third and fourth. A pilot titration provides only a rough estimate of the endpoint and should always be followed by a more accurate and precise full titration. We will discuss how to use the result of a pilot titration later in this video. Here, we will use the titration between an unknown HCl solution and a 0.1 molar NaOH solution as an example to demonstrate how to perform a pilot titration. However, before we start, let's first get our burette ready. Which step should we take to prepare the burette? Select all that apply. Yes, we should always rinse the burette with DI water, then the titrant several times to make sure the burette is clean. While rinsing, we should also check if the stopcock is working properly and that no liquid should leak out when the stopcock is closed. Now that our burette is ready to go, let's fill it with the known concentration solution, the titrant. Make sure the stopcock is in the closed position before pouring. Using the funnel, fill the burette to the top of the graduated markings. Remove the funnel, then open the stopcock briefly to drain any air bubbles in the tip. Once filled, the starting level of the solution should either be at or below the topmost 0 milliliter marking. What is the initial volume reading of the burette? Because the smallest increment in this burette is 0.1 milliliters, we must estimate one extra digit, so the correct answer is 0.52 milliliters. Make sure to record the initial volume of the titrant in your notebook. Now that the titrant is ready to go, we can move on to preparing the analyte solution, the unknown HCl. Start by accurately measuring a certain amount of HCl solution and place it in the Erlenmeyer flask. The titration between HCl and NaOH requires the use of an indicator, phenolphthalein. It shows a color change at the endpoint from colorless to pink, signaling the end of the titration reaction. We should add a few drops of phenolphthalein in the flask. Swirl the flask gently to ensure the indicator is evenly distributed in the solution. Place the flask under the burette. Adjust the burette so that the tip is aligned with the opening of the flask but is not touching its contents. You can put a paper towel under the flask to make the color change easier to see. To perform the pilot titration, begin by adding NaOH in large increments, approximately 2 milliliters at a time. After each addition, swirl the flask thoroughly to ensure the solution is well mixed. Unlike precise titrations, which require small, controlled additions of titrant to avoid overshooting the endpoint, the goal of a pilot titration is efficiency rather than precision, so adding larger increments is acceptable. As you add NaOH, you may notice the solution briefly turns pink before the color dissipates upon mixing. This temporary color change highlights the importance of continuously swirling the solution during the titration to ensure proper mixing. What indicates that the titration is complete and the endpoint has been reached? When performing a titration, your eyes should focus on the solution and watch for any permanent changes in color. A uniform color change that persists for more than 15 seconds while swirling indicates that the reaction is complete and you have reached the endpoint of your pilot titration. One note, the color of the solution at the endpoint reflects the quality of your titration data. For a precise and accurate trial, aim for a very faint pink color, which shows that you've just reached the endpoint, where the amount of HCl and NaOH is close to a 1-to-1 ratio. A darker pink color indicates you have added too much NaOH and overshot the endpoint, resulting in less accurate data. However, in a pilot titration, a rough estimate of the endpoint, This color change is acceptable. Based on the final volume reading below, what is the total volume of titration we added to reach the endpoint? The total volume would be the final volume minus the initial volume, making the estimated volume to complete the experiment 33.48 milliliters. Congrats, we have finished our pilot titration. What should we do next? After completing the pilot titration, we should proceed to the full titration. Remember, the pilot titration provides only a rough estimate of the volume needed to reach the endpoint. Its results should never be used for actual data analysis. For the full titration, you can save time by adding approximately 90% of the titrant volume, determined in the pilot titration, all at once. This amount of NaOH will not completely neutralize all of the HCl in the flask. Next, add the titrant in smaller increments of about 0.2 milliliters, swirling thoroughly after each addition. As you approach the endpoint, it will take longer for the solution's color to stabilize. Reduce the increments to even smaller accordingly. Stop the titration when a permanent faint pink color is observed. This indicates a much more accurate titration result. Remember, while the pilot titration helps save time by speeding up the addition of most of the titrant, it is crucial to slow down during the full titration to ensure accurate and precise results. After all, titration is an analytical technique that requires careful observation and precision to produce reliable data.